Welcome viewers to this special tutorial. Today we'll be looking at sequence, and under sequence we'll be treating arithmetic progression or linear sequence. And under linear sequence we'll need to know the definition, also know how to find the end stem of the sequence, the sum of the first end stem of a sequence, relationship between the end stem and the sum of the first end stem. So we now go down to geometric or exponential sequence. So under it we still find the same thing, definition, end stem, down to sum to infinity. So let's now start with arithmetic progression. So in arithmetic progression, a sequence is a linear sequence if each term is gotten by adding a constant term. So I'm saying that if you want to get the next term, you still add the same thing to each of them so that you get it. As an example, I'm saying a sequence if it's a linear sequence if a constant term is added to get the next term. So I'm saying that 1, 2, 3, 4 is a linear sequence because you keep on adding the same thing 1, 1, 1 to get the next term. So that's an example of is an example of an arithmetic progression. Also 4, 8, 12 also is an arithmetic progression. It's an arithmetic progression because we keep on adding the same constant term. Check it, 4. If you keep on adding 4, you get the next term. So that's the definition of a linear sequence. So the next thing we are going to do now is the end stem of a linear sequence. The end stem or the last stem. So if you don't call it end stem, we call it what? The last stem of the sequence. So we are going to get an expression for the end stem of a linear sequence. So assuming T1, T2 are the terms of an arithmetic progression. So let's call the first term, maybe let's use the one where we use, let's use 2, 4, 6 as it. So I'm using this. I'm using 2, 4, 6. So you notice that our T1 here is 2. Our T2 is 4. Our term 3 is 6. So let's relate this. You notice that this first term is settled. Okay, let's get to this second term. You notice that second term is if 4 is the same thing as 2 plus 2 minus 1 times 2. Check it. 2 minus 1 is 1. 1 times 2. So 2 plus 2. So this 2 here is the first term. We normally denote it with A. So this is the first term. Why the 2 here is the term 2 here. That's the 2 here. So it's the number of term. Why 2 here is the common. Okay, I didn't tell you that constant term. Sorry, that constant term that we normally add here, the constant term is called the common difference. It's called the common difference. So we normally denote it with D. So that constant term that you normally add to a linear sequence to get the next term is called the common difference. So this 2 is the common difference. So let's check for 6. So 2 is always there, and what is here is 3. So 3 minus 1, and the common difference is always 2. So it's correct also because 3 minus 1 is 2. 2 times 2, 4. 4 plus 2 is 6. So generally now, if you are looking for any end stem, it's always the first term we denote A as the first term, n minus 1 d. So where A, some will use it term 1, we use T subscript 1 is the first, A is the first term, while n is the number of term, and D is the common difference. So meaning that once you know the first term, the particular term, you can get and the common difference, you can get the term you are looking for. Example in that question, now we are asked to find the sixth term of the sequence 2, 4, 6. We are asked to find the sixth term of this sequence. Without wasting time, the term 6 is the first term, which is 2 plus n is 6. 6 minus 1. And the common difference, check, is 2. So the answer is 2 plus 6 minus 1, 5. 5 times 2, 10. So 2 plus 10 is 12. So the sixth term is 12. So that's it. So let's go over to the sum of the first nth term of a linear sequence. So the sum of the first term is just the sum of the first nth term is like if you are given a linear sequence with term t1. Do you get? So okay, let's see t4. If you want to, let's denote s subscript n as the sum of the first nth term. Let's denote s subscript n as the sum of the first nth term. So you notice that if you want to get the sum of the first term, the sum of the first two terms, so let's assume C2 as the sum of the first two terms, so which is T1 plus T2. That's it. Why the sum of the first three terms is T1 plus T2 plus T3. Again, the sum of the first four terms is T1 plus T2 plus T3 plus T4. So let's get a formula here. Let's notice something. You notice that if I do the sum of the first three terms minus sum of the first two terms, what do you notice? I'm saying this minus this is the same thing as T1 plus T2 plus T3 minus T1 plus T2. You notice the result will be T3. Yes. Again, let's check another one. If we do the sum of the first four terms minus sum of the first three terms, you notice it's T1 plus T2 plus T3 plus T4 minus T1 plus T2 plus T3. What do you notice? It will give us T4. So what do you notice? The subscript here is 3. The subscript here is 3. Why 2 is here? And 2, the relationship between 2 and 3 is 2 plus 1. So generally now, if you asked to find the nth term of an arithmetic sequence, it's the same thing as finding the difference between the sum of the first n term. As you can see, this is 4 minus term, which is n minus 1. So this is a very, very important formula. So this is the relationship between the sum of the first nth term and the nth term. So it's a very, very important formula. Okay, since we've known the relationship between the sum, let's now get a formula for the sum of the first nth term of an arithmetic progression. Let's get it. So assuming we have a sequence. We are to find the sum, which is t1 plus t2 plus t3 plus t4 down to tn. So remember, our aim is to find the formula for the sum of the first n term. And we know that we normally call the first term a. Why the second term is, remember from our formula, that term n equals a plus n minus 1d. So I will apply it here. So term 2 is now a plus d. Term 3 is a plus 2d down to the last term, which is a plus n minus 1d. So that's it. So I will just replace it with a and the common difference. Again, the same sum, we can start from the last one, which is a plus n minus 1d plus the term before that one, which is a plus n minus 2d, yes, down to a plus d and a. So we just started from the last and sum to the first. So this is equation 1, this is equation 2. Let's add the two equations. Add equation 1 and 2. We have 2sn. If you do this plus this, you get 2a plus n minus 1d. So I'm adding the first here and the last. So the same thing, the second and the second to the last here. Or second to second. First to first. Second, you still get 2a plus n minus 1d. So you keep on getting the same thing. Do you get? You keep on getting the same thing. So what we have to do now is, remember n. So meaning that the sum, imagine if you are giving, like example, x plus x is 3x. So meaning if it's 3. So since it is n, so we now have that the sum will be 2a plus n minus 1 times n. Do you get what? Because we are adding to nth term. If you are, maybe if you add 2 plus 2 plus into 4 is the same thing as 2 times 4. So that's what happened. And we are to find sum of the first n term. So from here now, sum of the first n term is now n over 2, 2a plus n minus 1d. So this is very, very important. This is a very important formula. So another thing we can, if you notice again, you notice that if you see, look at this, you notice that 2a is a plus a. Yes. Because 2a. So, and again, we've noticed that a is the first term, while a plus n minus 1 times d is the nth term. So it's the same thing as, if you don't use this first one, so I'm saying that if you don't use this first one, you can use this second one depending on the equation. So we use this one if you know the first and the last term. But we use this one if you just know the first term and the common difference. So that is the two formula we use to find the sum of the first n term of an arithmetic progression. So let's go over to the geometric progression.